This will be a very quick lecture on force distance graphs. They're a pretty straightforward idea. A force distance graph shows the force applied on an object and the distance the force has been applied for. Because the area under the curve of the graph equals the force applied times the distance traveled, the area under the curve of a force distance graph is equal to the work done on the object. So if I draw a line here, you can see that the area under the curve here is going to be the total force being applied times the total distance, so that'll be equal to d times f, which is equal to work. As a quick example, I'm kind of cheating and just borrowing this example from a previous lecture. The total work here is going to be 4 times 5 times 1/2, which is equal to 10 joules, plus 25 joules, that's the area of that rectangle, plus the area of this triangle, which is equal to 10 joules. And because this force is negative, it's doing negative work, so that's going to be negative 6 joules. So altogether, the total work done on this graph is equal to 39 joules. As a quick example problem, we can say a 5 kilogram cart moves at 10 meters per second. If this graph shows the force applied over the distance the cart is pushed, how fast is it moving after 8 meters of travel? So this is equal to the work. I can see that that work done on the cart is going to be 80 joules, 1/2 base times height. The mass of the cart here is 5, and the initial velocity is 10 meters per second. So that means the initial kinetic energy is 1/2 times that mass times that starting velocity. So that's going to be equal to 250 joules when you put that into your calculator. And the work being done on this is positive 80 joules, so 80 joules of energy are being added because work is equal to the change in energy. So the final kinetic energy of this is going to be 330 joules, so that means that the final velocity, plugging in 1/2 mv squared, the final velocity will be 11.5 meters per second. So that's an example of using a force distance graph in a problem.